Let's check out this practical application of geometry nodes. At work, I've been animating on a shot of a wind farm. Nothing unusual there. This time I chose to explore some things with geometry nodes instead. For example, I created an offset in the blades of the wind turbine since they don't always rotate perfectly in sync. With this practical example, we'll learn some fundamental stuff about Blender's geometry nodes. It doesn't really matter what shape you're going to use because we're going to delete the shape. We only need it because this is going to be the base of our geometry nodes. I renamed this cylinder to turbine, for wind turbine that is. And then I'm going to split my screen. On the left side I have a smaller panel that's going to be my camera view or my viewport. And the larger part of the window is going to be used for geometry nodes because that is where the magic is going to happen. Let's rename this to turbine as well. Then make some room and search for primitive, mesh primitive, and from here choose cylinder. Now we can put the cylinder into the geometry node output and nothing really changes because it's really the same setup. You can change the vertices right here, the resolution that is. I'm gonna set it to 12 for now because I don't want it to be so heavy on my computer. Because what we're gonna create right now are gonna be the instances. And when we scatter the instances around the plane, I'd rather have them a bit lower than too much, just to be safe. A wind turbine is usually built on top of a monopile, and the tower and the monopile are connected by a transition piece. This transition piece is also a boat landing, usually, and we're gonna make that, because that is the part that sticks above the water. So in the cylinder node we have these selection sets, top, side and bottom. So let me quickly grab a set position node to show you what this is going to be doing. Place it here in between and use the top to make the selection. As the name suggests, this selected the top of our cylinder, and when we use the offset you can see that the top part only moves. Perfect. Actually we don't need that, I could have showed this anyway, but if we use scale elements, place it in between here, again use the top selection and scale it down. We can have the cylinder be tapered. For this particular case it doesn't have to be that much of a taper, so I'm gonna do it roughly about 0.9 and we can always tweak this later. So I'm gonna use a frame, I'm using the short key Shift P for that and rename that here, and the side panel use it, rename it to base transition piece, and then copy over the name also in the labels tab. I should do that. Yeah, there we go. This is to keep it nice and organized for you to follow as well, and for me as well. So again, add another cylinder, and this cylinder we're gonna join. Ctrl Shift and right mouse drag the two I want to join, and then it automatically is gonna create a join geometry node. Because they're the same, you can barely see it, but if I change the vertices, you can see that it really is there. Now, I'm gonna use the depth and the radius to adjust it. And really, I'm just looking for a flat pizza kind of shape. So, there we go. Now I'm gonna look up the transformation node. And then I'm gonna use the translation to translate it up. As you can see, our radius is 1 meter and our depth is 2 meter. The depth goes both ways. So up and down from the middle, that is 1 meter. If I want this piece to rest on top of it, I have to have the translation up by 1 meter. To make this a bit more user-friendly, I'm gonna add a math node, then set it to 1. And for now, just set both values to 1. Plug it into here in the depth value. Now I'm gonna search for input value, place it somewhere here, and use that for the translation. That isn't gonna work, of course, because the translation is a vector. But we'll fix that later. So now it transposes everything on both, or on all axes, all 3 of the axes. We don't need that, of course. I'm gonna search for a combine vector, place it in our frame, use the vector as the translation, then grab the add node and make another value node because we still need that. Set the value here. Then again, place the value in the Z, because we need to translate the Z value. I need to set the value to 1, there you go, and multiply that value by 2, because as I said before, the depth is going up and down. So if it is 2 meters of depth, it is 1 meter translation. To make the shape of the platform a bit more interesting, I'm gonna insert a extrude node. And for that extrude mesh node, we have to make a selection. I'm gonna use a compare node set to greater than to define our selection. I'm gonna leave the spreadsheet down here so you can see that, for example, the cylinder has 24 vertices, 36 edges, and 14 faces. That is useful information because every face, every edge is numbered. And with those numbers, we can create a selection. So to create a selection, I'm going to use an index node and compare that index to another integer value. So as you can see here, this does work. Our setup right now does select part of the mesh and extrudes it, but it's not what we really want. We need to have some more control. So we're going to build that in just a second. There are different types of comparisons you can do. You can choose whatever is needed in your case, but I'm going to use lesser than and greater than. I'm going to use a Boolean math and then duplicate the comparison node we already have, plug that into the Boolean as well, set the Boolean type to not equal, and then set our first comparison node to lesser than and the second to greater than. So every value that lies in between here is going to be selected. Everything that lies lesser than or greater than falls out of the selection. So I can use these two nodes to create a range for our selection. So I adjusted some settings for the transition piece so we have a bit more resolution and made it a bit higher. Now let's continue on with the tower. I created again a frame, and within this frame there is a curve line. And the curve line is going to be the distribution for our tower sections. If we want our sections on the line, we have to have an instance on points and place that in between there. Nothing really happens. We can visualize it here. Still nothing really happens. This is the line we use to distribute. And with this node, we're gonna say what instances we are gonna use. Now, again, because it's really just a cylinder, so we're again gonna use a mesh cylinder. Tower, no, sorry. That was stupid. Cylinder, that's what I need. Imagine there was just a complete tower in there. That would be awesome. No, we need a cylinder. We're going to use that as the instance. And with the instance set, we can now adjust some parameters in the node. Set it to whatever you like. I need it to be a bit smaller. And for now, 12 vertices is fine. All right. Sorry, I came back on the decision I already made. I'm not going to use a curve line. I'm going to use a mesh line. And we'll see why in a minute. Reduce the radius and maybe the depth so that the cylinders just barely touch each other. And then to visualize where our tower needs to sit on top of our platform, I'm going to use this geometry node, join geometry, and join that with the tower we already have. So that creates another join geometry node. And you can see that it is not quite high enough. So we need to offset the start location. And I can do that right here in the mesh line node. For this, I thought it would be clever if it worked all together. And maybe we can achieve that. So instead of adjusting the size manually, I'm going to use the value and plug it into, no, that cannot be. Maybe it's better to use the combine vector or combine XYZ. And when I do that, you can see that we nearly are there. We only need another math node that's going to add a value we can set on top of it. And then it will have the perfect offset. So our tower sits neatly on top of our platform. For this project, I wanted to be a little bit more creative with the wind turbine because I create them all the time. And I just want a bit more abstract, stylized, and just a bit more creative freedom in this project. I mean, it's not for a client, it's just for fun. I'm going to create a Mondrian version that is a Dutch painter. You can look it up if you want. It's something like this. And to do that, I want every section of the tower to be slightly offsetted in a random way. So we're going to use translate instances. So we're going to use translate instances. That node is going to be placed at the end of our flow. And you can see that it offsets the tower. And as of now, it just does it as one block, but we need it to be on individual basis per cylinder. Right. So I'm going to create a random value, set this to vector for now, and plug it into the translation. This is sort of what I want. The only thing is we can have it translate up on the z-axis. So I'm going to reduce the max value for the z to 0. There are two things I want to do. I want the tower to taper off when it's going up. That is what usually happens. But of course, this is not a usual tower, so it's going to have this offset. But still, it needs to taper when it comes to the top. The second thing we need to do is I want the base of the tower to be in the middle. And the offset can increase into whatever direction it wants when it comes to the top. So for that, we're going to need a selection. And that selection is usually going to come from our mesh line position. I'm going to insert a vector math node because I want the random value to be multiplied by the position of the line. And the position of the line is going to be from 0 to 1. So everything at the bottom is going to be 0. And whatever setting multiplied by 0 is going to be 0. Thus the offset, the random offset, is going to be nothing. So the base stays in the middle. I hope that makes sense. I'm going to set it to multiply and add. And I'm also needing a map range node. It's sort of doing what I want, but I think I need to flip the position. For me, it works best when I set the minimum to 1 and then increase the max value so the lower part stays in the same area as I wanted, and on top they slightly more get a random offset. I'm going to duplicate the position because we need the position again, and I'm going to use the multiply vector node, this time multiply only. So this time, place the vector math node in the scale value, and our tower is completely gone. I set this to multiply. Later on, I decided I just needed a multiply add node again. I don't know. With another map range node in between there. And that creates kind of the effect we need, only upside down. So I'm gonna make sure that the min value is higher than the max value. That will invert the curve. Then it's just a matter of playing around with some settings. And at this point, I noticed that the multiply add node was also using the z-scale, and I don't need that. That created a weird offset in the z-axis. So if I set it to 0, that would be fine. So by placing the result of the map range into the x and z and keeping the z value at 1, we keep the scale on the z-axis the same all over the place. Now the tower tapers towards the top, and we can go on and maybe even introduce some random scaling for each instance as well. After I tweak the mapping range node to get a result that I really like, I can continue on and do just that. I'm only gonna need the random value node, and that random value node I'm gonna have to set to float. And now we have to do the same trick. I'm gonna use a combine vector node, and using the x and y and keeping the z the same, we can have a scale difference in both directions, excluding the direction from the z-axis. And you can see what the result is. Nice. Now play with the max value, play with the min value. You can also play with the random seed. Well, let me think, what are we gonna do next? We got the transition piece, we got the tower, it's tapering down towards the top. And we're gonna need something that is called the nacelle. The nacelle is the housing on top of the turbine. Speaking of the top of the turbine, I do want my tower to be a little bit higher. So I can increase the count right here of the mesh line. That weirdly enough gives us an inverted result when it crosses the threshold. That is totally fine. Then we just need to adjust the mapping range node down here. But let me make this a little bit more automated. So if you can see, we have a count of 10. And our mapping range node minimum is set to 8, roughly. I just chose 8 because it's easier to do math using 10 and 8 than the decimals as well. I'm gonna set that math node to multiply and add. I'm gonna multiply it by 0.5, so that's actually dividing it in half, and then make an addition of 2. Plug that into the minimum of the mapping range node. Increase our value right there, and you can see that it now grows nicely and we don't have that inverting at the top. Right now I'm gonna create the nacelle, and the nacelle is the housing on top of the tower of the turbine. For that I'm gonna use a mesh primitive, a cube in this particular case, and right here somewhere, yep, we can continue on. The nacelle is gonna be a cube and we need to translate that cube up, so we're gonna use a transformation node for that. Feed the cube into the transform node, and use the Z to move it up. Then don't forget to connect it to your geometry nodes, otherwise you won't see it. And if you scale it up, you can see it's right there. So place it into position right about there. I place it at 12 meters high, and I'm gonna use the scale to get it into position. To be honest, later I realized that I should have used the size parameters in the cube node. I come back to that and I will do that in the end. Now we need to create the hub, and the hub is going to be the part that connects the blades. For that I'm going to use a UV sphere, and the UV sphere will sit in front of the cube. Now, so we need roughly the same placement. I'm going to use one because that's easier to work with. So we determined the height, and the sphere radius should be half of the height of the nacelle. Right, what I want to do now is use the nacelle to boolean out the other half of the UV sphere. To make it a bit more automated, I'm going to use a vector node and set that to 12. Use that in both translations. Use a math node and then, use the math node and place it in between here. That math node should be set to add, and you can add to the position on the Y. Maybe you can also set it to subtract, so it could be a positive value as well. Because we like to be positive. No, I don't care, bro. Do whatever you want. With our nacelle now in place, 12 meters high, and our hub 1.5 in front. Cool. We can now use a mesh boolean, search for mesh boolean, and when you have found your mesh boolean, you can use the two meshes, the hub and the nacelle, to cut off the other half of the hub. If you want to visualize it, because now you can't see it because the nacelle is really blocking what is happening, you can temporarily cut the line here between the transform node and the geometry. And you can see that our UV sphere, our hub, is now split into half. Perfect. All right. Everything seems to be looking all right. I want to play with the scale a bit. Yeah, let's do it. Okay. I'm going to use the Z value to get the hub a bit more sticking out. I'm going to choose 1.5 here. And actually, we can maybe use the start and end point of our mesh line to connect the height of our tower to the position on the Z-axis of our nacelle, and with that also the hub. I'm gonna replace this vector node with a combined XYZ node. Set that to 12 just to visualize that it's on top of where it needs to be. And then use this input right here that is set to 10. Create a math node here. Connect that math node up. Plug that into the Z value of the combined XYZ. And then say +2. And now with every whole number our tower increases in height, our hub grows with it, +2, so it sits neatly on top. So for that specific reason, I chose to change it from value to integer, so we don't have that gap when it's on a decimal. Let's just keep it like that. I'm making just a little bit of room so we can work on the next part. I'm gonna reroute this noodle all the way around so it comes to the back here. As you can see, the height of the transition piece no longer works in correlation with the height of the tower. I think that is a problem to deal with on another day. First, let's continue on finishing this project and making the blades. So what I did is I created a cylinder and used the same method as before, scaled that using scale elements to taper it and place it into position so we have a reference for our blade position. Using two separate scale elements, I could fix the mistake I made. I scaled up my hub and then I lost my boolean because the nacelle wasn't really grown with it. So I changed that using a transform node and use those scale elements to transform the boolean mesh of the nacelle, but don't use that same boolean mesh as a mesh you want to see, of course, because I want to keep the nacelle a bit smaller. Okay, I think I'm going to use a different method. We have a curved circle and we have a curve to points node. Set the curve resolution to 3, so we have 3 blades, of course. I'm going to use a instance on point node. For now, leave the other turbine out of view for a second. I'm going to disconnect the rest of the node tree and just connect the blade setup for a second. Then I'm gonna use this blade we have created earlier, the cylinder, and then of course tapered it with these scale elements and place that into the instances. They're now facing upwards, and of course that is not what we want. But if we use the normal and plug it into the rotation, you see it all gets wonky. Now, that is not what we need, so I'm gonna use align vector to curve. Align Euler to vector. The normal shouldn't be plugged into the rotation, but into the vector. Choose your axis. For me, it's gonna be the z-axis. Then I search for instances, so I can find translate instances. When I move them over the z-axis, you can see that they move into place. Now we do have our blade set up, it's time to get them in the right position. And how we do that is by getting our curved circle into place. So we can use the position of the hub and place it into translation. All we need to do now is rotate it on the z-axis. It is the x-axis. It's always the last one you try, of course. And now that it is rotated nicely on the right axis, you can see that we have another problem. It doesn't rotate on the proper axis for the wind turbine to spin. We're gonna fix this. Get everything back into view and connect our blade setup to our existing setup. It's gonna use the vector right here that is in the z-axis set to -5.7. And that is actually gonna translate our blades up by 5.7. Set this back to 0 and it should be located perfectly. You should leave the value set to 0.5 on the y-axis because that translates the blades forward in front of the nacelle. The turbine looks fine, it isn't just fully functional. As we said before, the blades don't spin as they should, and that is because our pivot point isn't really located in between the blades. It is located at the center where the the cylinder we started our geometry nodes with, the origin lays there, right? You can see it's right there at the 3D cursor. So, actually what we have to do is we have to reset our origin. And how we're gonna do that is actually something I found online as well. So you see, we're all still learning every day. I'm gonna search for the attribute statistics and insert it right here after the blades. Right now it is connected also with the hub and I should not have done that. I will correct that later, but for now we continue. We create a position node as well and place it into the attribute. Then create a transform node and feed, of course, the geometry flow through there. Use the mean value in the translation. I don't have a duplicate, it's just a weird error. The blades are rotating from the right position, only they are translated up. So we have basically the same issue that we had before, we just moved it up a little bit. So what I end up doing is get this line here and disconnect it. And then I place the Boolean mesh here in the other join geometry node. With so continuing on with a vector math node, place it in between here, set it to scale m-1. You see our blades are now working fine. Using another transform node, we can now place it into position. Get the math node we just deconnected, place it all the way forward here. Then use that vector and place it into the translation. And now the turbine is working perfect. Using the Y value, you can rotate it. Alright, then I want to get the blades a bit more rounded at the top. So I'm going to use a sphere, use the same amount of rings and segments as the cylinder has. So in this case, it's 12. I'm going to use a mesh boolean and place the UV sphere mesh at the tip of the blade. So our scale for the sphere is going to be the radius times 0.5, because that is the factor we scaled down the tip of the blade. Using this setup and these two values, I can now taper the blade and also control the size of the sphere on top of it. Alrighty. Now it is just a matter of connecting everything back up. Boolean should now be the instance instead of the cylinder we had before. I frame this particular piece right here and name this reset origin blades because it's really nice to find this if I ever want to look it up again. So now this entire node tree is going to be our instance for a grid we're going to make right now. Bring up our group output, find a grid, set the grid to whatever size you like, using whatever vertex count you want. Use a mesh to points, and instances on point. Connect it up to the geometry output. And as I said before, get this right here and use it as an instance. There you go. I'm going to use a value to set the size. And let's make it quite big. So maybe 50. We got our wind farm right here. If you want to increase the instances, the count of the instances, you have to increase the vertice count here. I'm going to switch to integer because why not? We don't need the decimals. You have your counter right there and do the same thing for the size. Right now our blades are rotating at the same time, perfectly in sync, and usually that doesn't happen in a real wind farm, so I'm gonna try and offset them and have them distributed over our grid as 2 instances instead of 1. Now, join those 2 together. If I now adjust the rotation here, it doesn't work. So somewhere along the line, the origin has been reset again. We need to figure out where it is. If I create a rotate instances node. So using the rotate instances, I set the pivot point to be at 50 meters high. That is the value that I have set. 13 for the tower height, plus 2 for the height of the hub or the nacelle. So that comes to 50 meters high. With that offset in place, now the turbine is rotating perfectly. Finally, we can try and offset these blades from each other so they're not perfectly in sync. We use a scene time set to frame, then grab a combine XYZ node, plug it into the Y node, that is the rotation we need. We can control the speed by using a math node set to multiply. Grab this math node and place it in between here. You can use whatever factor you need. I'm going to use a low value, maybe 0.1, 0.2. Then I'm going to need a random value node, and I'm going to need another math node. With another math node in place here, set to subtract, we can subtract the random value from your scene time. So the scene time is going to use the frames to increase the value, each frame of course. And that is going to be subtracted randomly by a number. That is going to give us a random offset in our wind turbine blades. So I've set up a PBR texture here of a paper. Then I used a object info node set to random. I got my Mondrian colors in a color ramp and then combined those two using a mix RGB node. For now, the blending mode doesn't really matter. We'll come back to this later. The paper texture doesn't really project nicely onto our mesh because obviously it isn't unwrapped. So we can do that here in geometry nodes as well. For example, if I go here in between the tower and the set material node for the tower, we can place a UV unwrap node and a store named attribute node. We're going to use a face area. This face area is going to be our selection. We're going to select the top and the bottom. Those faces are larger than the other faces that go around the cylinder. We can do this by using a compare node. Compare the face area to a float value. Place the result into the seam because that splits the top and the bottom from the side polygons. I'm going to use a Boolean math. And in between here, let's make some room again. It's gonna be real crowded right here. Let's use the index. Get a compare node and set it to integer, and then the math type is equal. So this is gonna look if the index is equal to a certain number. So selecting an edge with a particular number, and along that edge it's gonna create a seam. Using a delete geometry node, we can visualize this. So place it in between here. It doesn't really matter, we can delete this node later on. And then fill the selection with our equal math node. And as you can see, let me rotate around. And as you can see, it deletes a scene along the side here. Perfect. You can adjust the number right here and see it rotate around. So if you want to hide your scene better, you can maybe place it in the back of your tower or turbine or whatever you are unwrapping. So moving on to the blades, I am gonna set up a brick texture. And again with the Mondrian colors, that is red, yellow and blue, and a white. There's a border color of a darker blue or maybe even black. It isn't quite working for me just yet. But we need to create a better unwrap. So let's go back over to the geometry nodes and unwrap the blades. So in here, I'm gonna go over to the section where we have the blades. Again, create a delete geometry node so we can see what we are selecting. Place its selection in between there. And I'm not gonna use the face area. I'm gonna see if I can split it right through the middle. So I'm gonna delete a bunch of nodes right here. And using a normal node and separate XYZ. I'm gonna use one of the x's, I'm not sure which one, but I'm gonna plug it into a greater than node and connect it up to the UV, of course. And also place it into the selection here for the delete geometry node so we can visualize it a bit better. If I set it to 0.1, you can see that it deletes the half, but not the half I want it. I want it to be front to back. So I think I'm gonna need the y-axis. And when I set it to the y-axis, you can see that it works perfectly. So this is the unwrap I need. I'm gonna delete the delete geometry nodes, go back to my node setup in the material editor, and use the period key to reframe your window. Right now I'm tweaking the brick texture and I find it isn't working quite as I wanted. Then I find that I should probably change the second color to mid-gray and the mortar to black. So we have our texture that goes from white to black and has a slight variation in the mid-gray section. And in the color ramp I'm going to use an extra color, set this color to be the dark blue, and the mortar should be black. And in the brick texture now change the color to 0.5, so it's a mid-gray. Now the bluish color we had created for the mortar should be on the outside, so because that is the black value. The white should be on the white value, of course. And as you see, I'm trying here to get the mortar to look right. It doesn't look right because it should be inverted. So I'm going to use a color invert node in between the brick texture and the color ramp. So now we have a color going from white to black. That will have our colors map white, red, yellow, blue, and dark blue to the brick texture. And everything that is mid-gray is going to be red, yellow, or blue. There are two things I'm noticing right now. The color between the blades and the tower and the rest of all things is just not completely matching. Also, I would like to have the tower have a border as well. So we're going to do those two things. The shade smooth node in the geometry nodes isn't working as I wanted, so I created this little setup using an angle node, using the on-site angle, using a compare node, setting it to greater than, then using the radians so we can set an angle, and that determines how it is going to be split. Instead of having this in the selection of the set to smooth, I'm gonna insert another node that is a split edges. And now use that selection we created for the set shade smooth and plug it into the split edges node. And like I said before, I want to create a border for the Mondrian texture as well. And how we're going to do that is I'm going to use a bevel node. That bevel node is going to be finding the edges for me. Mix the bevel with a geometry node. Not a geometry node, but a node that is called geometry. Actually, don't mix them together, but use a dot product. That is a math node, a vector math node. Using the normal. All right, now we have to do a little bit of conversion to get it more visible using a map range node. If I flip the to min and to max, you can see that it's now more visible. Play with the min and max to get a harder or a softer gradient between the black and the white of your mask. This mask I'm going to mix in with the color. So we have this new mix node. This should not be a color, but this should be a vector. So, and use the lower color to get the border color we need. That is the dark blue. If you want a thicker border, you should adjust the radius of your bevel. Also think about increasing the samples, otherwise you get a grainy gradient going from black to white. In between there, I think I'm going to use a math node set to greater than, because I want to filter out the gradient and just have it either black or white. You can set it to lesser than if you want to flip the mask. As you can see, the colors between the blades and the tower don't match. I probably shouldn't set this to color. Maybe overlay would be a better blending mode. Now this is looking fine. I'll go on and create a back wall using just a plane. I'm not going to use this procedurally. I'm not going to do this procedurally. The bevel isn't working because I need to apply the scale. When I do that, now the bevel should be working correctly. Adjusting the profile while I'm scrolling and place it nicely in the scene. Then bring it up a little bit more. And there you go. This is our final result. I'm sorry if I lost a little bit of energy here. I was recording for maybe 2 hours, fumbling and stumbling my way through. Hopefully the editing would make it a bit more fun. If you enjoyed the video, please leave a like. If you have any questions, comment down below. And as always, stay creative. I'll see you next time. Ciao.